In this work, we present REBEL, rule-based and experience-enhanced learning with LLMs for initial task allocation in multi-human, multi-robot teaming. Multi-human, multi-robot teams harness the distinct yet complementary strengths of humans and robots to collaborate and accomplish a variety of different tasks. Initial task allocation involves generating an ITA plan that strategically assigns tasks to team members. However, MHMR teams are often deployed in diverse real-world applications with complex user preferences at play based on the situation, as shown here. Thus, the ability to incorporate these multiple preferences during ITA is essential. We propose REBEL, an ITA framework that can adapt to multiple user preferences and handle unforeseen circumstances like sudden team composition changes. The first two stages of our framework comprise knowledge acquisition. During stage 1, the LLM generates helpful rules to follow when performing ITA for a single mission objective that is provided. During stage 2, the LLM gains practical experience by performing ITA for randomly generated missions given the objective and generated rules from earlier. During stage 3, a new mission is provided along with multiple user preferences to reflect the complexity of MHMR teaming in the real world. We introduce experience and rule retrieval modules that enable the LLM to reference the most relevant rules and experience data from stages 1 and 2, further enhancing its ITA performance. We evaluate REBEL in a real-world scenario which involves assessing pollution leakage from warehouses. The mission procedure consists of 2 steps, as shown here. The details of the human and robot models are illustrated below. The travel speeds of the robots depend on the control mode, which could either be autonomous or human teleoperated, as shown in the animation on the right. Here is the demo. REBEL generates an ITA plan given a mission and the commander's preferences. To minimize the mission time and ensure accurate POI classification, we observe the UAVs are assigned to further POIs as they are faster than the UGVs. Robots are able to navigate autonomously while the humans are busy classifying POIs. And finally, skilled human operators instead of robots are assigned to classify the harder POIs. The first experiment evaluated single objective optimization. REBEL outperformed ATRL, the leading reinforcement learning approach, or came within 10% of it, all while requiring fewer data samples and less training time. The second experiment evaluated multi-objective optimization. Unlike experiment 1, 3 objectives were given to the ITA system simultaneously, and 1 was designated to be the priority. REBEL was the only approach that performed ITA while accurately reflecting the nuances of the priorities described in the user preferences. The third experiment evaluated situational awareness. Team members were randomly added or removed to reflect real-world unpredictability that is difficult to account for during training. REBEL effectively handled these last-minute changes and showed promising results when combined with ATRL to form a powerful hybrid approach.